Right.
Yes.
Hello?
Hello, can you hear me now? Oh,
Yes.
oh, thank you. Thank you, Andrew.
You're welcome.
Okay. So now we can hear each other. Okay. So, recording. The recording is from now. Okay. Recording is on. So let me share on the screen. And the screen was frozen too. I cannot share.
We're going to share your whiteboard.
I cannot share the course I have opened earlier.
Oh, go to the course on the screen.
This is the course.
Okay, now check. Now check the share screen.
Share screen?
Yeah, no, the share screen.
Okay.
Wait, no.
Share is here.
Yeah.
When I share the screen, oh, now I can see it. Yeah, very
There you
good.
go. Select that.
Okay. So look like now it's go back normal. Okay. All right. Thank you.
You want to use your whiteboard?
No, I use the.
Okay.
Yeah, the whiteboard is not connected.
You just open the whiteboard number in the same one.
Yeah, I have whiteboard here.
Okay. Open it.
But this whiteboard here is difficult, right?
No, you write it on here. Just open it the same number.
Okay. So I'm open up the sign in. You have to sign in to use the whiteboard app.
Yeah.
But from my computer, I don't need to sign in.
You just have to open up the whiteboard number, like whiteboard 51 or 52.
Yeah. Okay. That's okay. I can just use these lines. Okay.
So you just have to open the same whiteboard number.
Just create a new one. So I can write on this
Yeah,
one.
you can share that one.
Okay. Let's say today is November 12th. And can still see there?
Yeah,
I
go
don't-
to share screen.
So I need to share the screen.
Yeah, share screen and then select the whiteboard. The
Whiteboard is not here.
Whiteboard is.
Yeah, it's not connected.
Oh, here. Click sign in.
I cannot sign in. Very strange. No, cannot. Cannot. That's okay. The class already started. I have no time to fix this. That's okay.
Okay.
Don't use that.
Cancel.
Oh, cancel?
Yeah.
It's not working.
It's not right. Okay.
Yeah. Well, thank you. Oh, but here block me.
Do this.
I don't know why. Dang.
I'm not sure what's going on here. Click the task manager.
That's the manager.
And here, you can cancel. You can cancel Microsoft Whiteboard.
This one?
Yeah. Open up. And right here, open up. Or right click and do cancel.
Right click.
End task.
End the task.
Yeah. There you go.
I need to
That's it. You can close it.
close it.
Yeah. And click on it one more time, Mikey.
Whiteboard.
Yeah. I think your left to right may need to get upgraded.
Yeah, last time I just click here. I can work on the whiteboard.
Yeah.
And just copy and paste everything.
Yeah.
Okay.
Your laptop might get a memory.
Mm.
This is good.
Not coming out.
Yeah. And you just hold it back to match the screen.
Okay. Let's see. Can we use it? Whiteboard?
Yeah, and what number is it here?
This is 48.
So there you go. So let's share the screen.
Share the screen.
Yeah. Let me share that. Yeah. Share again.
Share
And share left.
this one.
Yeah.
This is the whiteboard.
Yeah. Or same thing. There you go.
All right. Can everyone see my whiteboard now? 11:12 Zoom meeting?
Yeah.
Oh, thank you. I don't know why computer was frozen. Couldn't work. No, good. Okay. So who will give me the first question from chapter 9 or chapter 11? We skipped chapter 10. So just to finish your chapter 11, chapter 9, hypothesis testing, we can move on to chapter 11. Chapter 11 is different type of the problem. Okay. So is anyone working on chapter 11 already? Or is still working on chapter 9, hypothesis testing? If you're still working on the chapter 9, we can still go over our assignment of the chapter 9. Let me stop the share this one. And let's go to chapter 9 assignments. And you say that I click on
You can snip it and copy it over.
this. Okay. I'll try to go to the assignments now. Chapter 9 assignments. Chapter 9. So let me share. Now you know what I'm doing here. Chapter 9. Say this one. All right. Can you see my side here? Chapter 9 homework hypothesis testing with one sample.
No, I don't see a sign right now.
You don't see yet? Oh, try again. Oh.
The snippet. Snippet into it. Go to the question.
They cannot even see it.
I don't go to the question.
No, share.
Yeah.
I need a share first. Oh, something wrong with the sharing. Okay, share again. Share. Oh, and click on the right one. The
Okay.
homework,
Yeah.
I think this one. And share. Okay, I opened our chapter 9 homework assignment. Can you see it? Everyone? Yes? Okay, great. So among these homework questions here, do you like me to go over any one of these? Did you get all 100% correct? I believe my problems is very similar to yours, okay? And this is coming from the same test bank. And the computer just randomly select problem to everybody. And if you have question on the number 10, should be similar to my number 10, okay? If you have question on chapter 9, question 9, you can use my version or you can share it with you, okay? Your own version here. So let's start with Michelle. Do you have any question from your homework assignment?
Not at the moment.
Did you finish chapter 9?
Yes.
Oh, you did already? Okay.
Yeah, I'm working on 11 right now.
Oh, 11. Okay. That's good. Then we can go to the chapter 11 as well. Because last week we discussed about the chapter 9, right?
Yeah, I missed last week because I've been sick, but I did the discussion for it. So
yeah, that's fine. And some people already post the solution of the homework as well.
Yeah.
That will help. So let's come to assignments and again, and let's go to chapter 11. Okay, chapter 11. The chi-square distribution. This is a different type of the distribution here. We use the chi-square. Okay, something different. And on your TI-84 calculator also shows a different function we need to apply. So when we go to my version here, the chi-square distribution, when you apply, you have to pay attention to degree of the freedom. Okay. Now the df is degree of the freedom. So like this one here, question 1. Can you see my question 1 now, everybody? Michelle? Is this too small to see?
I can see it okay.
It's okay. So have you done the
Mhm.
problem number 1? The degree of the freedom?
Yeah, so for that you just take the number of categories and you subtract 1,
Yes,
right?
that's right. Mm-hmm.
Okay. So
So
this one would be 5.
some problem, yeah, it's fine. You are right. Mm-hmm. Like this one. We have 6 categories. So you need to take the total number of the category, subtract 1. Okay. That's correct. But be careful with problem number 2. Question 2 is a test of the homogeneity because we have contingency table. The table there's raw data and the matching with the column data. Look like the table from the question 3, a table style. That's we call row and column category differently. So when you work on the degree of freedom, you need to take care of both of them. Okay. I believe is you need to think of them. Row number subtract 1 and multiply column number subtract 1. Okay. So for this problem, it should be and we have to multiply. We have 6 in column variable. Okay, like this question 3, column variable A and B. Then the row variable, we also have row variable, population 1, population number 2. But this question 2, we have 6 categories. So each one we need to subtract 1, then multiply together when you have contingency table. Okay. So should it be 5 times 5 give us 25. Okay. 6 minus 1 from the column category. Then 6 category from the row variable. So 6 minus 1 is a 5. Another one also 6 minus 1, 5. 5 times 5, we had to multiply. So come out 25. Okay. Let's go to question 3. You are conducting a test on the homogeneity of the claim that the 2 different populations have the same proportion of the following 2 characteristics, and they show the data there. Problem is asking, what is a chi-square test statistic? This is a different type of the test here, different from we used to do for the mean standard deviation only. This one is kind of comparison, the relationship between the first category and the second category. What their relationship here? Are they independent or they are dependent on each other, affecting each other? Like a category A is affecting our population number 1. For example, we are voting for something, right? Like presidential election, okay? And let's assume A is presenting Democrat and B is a Republican. So we can kind of think about people belong to Democrat or Republican. And then we check the population number 1, and then there's another group, population 2. We try to see any difference here because we join different 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 part, right? If you join the A, if that will affect our population 1, population 2, if you think of the voting, right? Selecting some candidate without make a difference. So this is the data they collected. And from all the data we collected here, we are going to draw a conclusion. It's really related here, depending on you are from California or your population too from New York, the East Coast. Will that be different related to make the difference of the vote, right? From Democrat or Republican, 2 different party here. So that's what we are doing here, chapter 11. Compare the relationship and using the 2 categories. So this will be, I think, it's a tool, very useful tool for the real life decisions here. So chi-square test statistic, we have formula here from the textbook. You read it, chapter 11, you will see there's a formula for homogeneity test. There's a formula for independence test. But fiber test, these all belong to the chi-square distribution. And the reason we call chi-square, because we kind of compare relationship here, okay? It's a different way from the earlier chapter there. And it's kind of comparison between the 2 categories. But from each category, matching with another category, we can count the people. How many people vote for this all belong to the other one, okay? So for this one, chi-square test, actually, if you use the formula from the book, it's kind of complicated. But you use your TI-84, it's very easy, okay? So I would like to show you, take this one as an example, how you use your TI-84, okay? So let me copy this one to the whiteboard. And is my whiteboard working?
Yeah.
Yeah? If not working, I'm going to, copy this one, put it on the whiteboard.
Yeah.
No. Yeah, the enemy. I don't know, this is the way I know how to do it. Okay. I click on this, and then we pop on the new. Okay. So Control C. Then I'm going to put on the whiteboard now. Okay. Oh, yeah, that to put here. Control V. Yeah. Yeah, very good. So we can share the information together. I can move this one up here. Then I can write on here, right?
Yeah.
The pen. We needed some special pen to write on the whiteboard. Okay.
Share your Zoom screen.
Okay, thank you. Thank you. So this one, as an example, okay, in chapter 11, we needed to know how to use your TI-84 for 2 things. One, for this question 3, okay, for homogeneity test or the independence test, okay, you can use this method I'm going to show you now. Let's go to stat, okay, and go to the test. So I place on stat and go to the test. Then you move downward to the one on the screen. You will see chi-square test on your TI-84. And chi-square test, you hit the enter. So you will see chi-square test need your input of the observed value and the expected value. So that's remind you we have to do the data entry. Okay. And to do the data entry, how can I do it? Just go back to stat, hit the stat again, and edit. You will see the screen pop out edit there. So you will use the edit, just hit the enter. And when I hit the enter, I can see 1, 2, 3, 4, 5, 6. There's a list, L1, L2, L3 to the L6 for you to input the data. But we are not going to use this one, I'm sorry. Because for the chi-square test, for the regular test, we will come to this side here to do the data entry. I will say until chapter 10, okay, chapter 9, you need to use this one. But for chapter 11, it's very different, okay? For chapter 11, you have to do differently. So what do? You need to use a matrix. I don't know, have you remember the matrix from the algebra class? Matrix? I'm going to erase this because my book cannot change. Okay, so you will conduct the chi-square test. But before the chi-square test, you need to do something first, okay? You are going to use a matrix. So use a matrix. Maybe I just use this one and put it here. Type out. Matrix, okay? And on your calculator, you will see the matrix under the blue color key. So you need to hit, how can you get the matrix? First, you need to do second, okay? Hit it at the bottom key on the left-hand side, second. Then go to 1, 2, 3 below. You will see x -1, okay? Oh, x and raise of -1 power, like that. X -1. Now the button, above this button, you will see matrix there, okay? So that's the one you need to hit the enter, okay? So when I see x -1, hit the enter, okay? Enter. And when you hit the enter, you will pop out a matrix here. So second, x -1, your screen should pop out the names as you name, and is this math, and you need to edit here. This is the screen you will see. Can names, math, edit. Did you see this one? Your TI-84? I hope everybody follow me. Let's do one problem together, okay? At least you know how to do it, okay? So when you hit the button, second, and the button of the x -1, not the button, you will see above shows the matrix. That's what we needed to use, okay? So after you see the screen pop out the names, math, edit, you will come to the edit here. So you need to use your arrow key panel and move your key to the edit here, okay? So kind of like a highlight on the edit, then you hit the enter. The screen will pop out, okay? So you hit the enter on the edit, and you need to hit the enter here, okay? Then you will see something shows the matrix. Matrix with a bracket. Bracket is a symbol of the matrix in algebra. Okay, so they use a bracket here. And the bracket, they put the matrix A inside. That means you are going to do the input of the data under the matrix A. Okay. Matrix A. And later you will see there are fraction there. And your calculator should have some data from previously someone used. Mine shows 2 by 3, 2 and times 3 like that. That's a dimension of our matrix. Because look at this question 3, we have raw data and we have column data here, right? So that's why you need to give them dimension, the space for our calculator to input the data. So I look at our question 3, our data, where shows the number, right? We have 8 at the row of the A under the population number 1. We have 8, 144, then we have 55, 30. So we have 2 rows of the data and the 2 columns of data. So that's why you need to make sure your calculator shows 2 by 2. Okay, you need to change it that way. So if your calculator did not show 2 by 2, you need to make a change. Just use the arrow key, go to the right, and enter the right number. So make sure you have 2 by 2, okay? 2 times the 2 on the top, 2 by 2. And when you have that one, you hit the enter, okay? Just like a computer, mini computer. Every time you hit the enter, will change your screen here. Then you will see your screen will give you a big bracket, okay? You should have one big bracket and the space for you to enter the data, okay? So I will enter the data just according the question gave to me, okay? So I type 8, then after you type the 8, you need to hit the enter, okay? So 8 will stay on the first place. Then they will move to the second space, and the second space, you just hit the second number, 144. That's the 144 people belong to category A under the population number 2. We have 144 sample there. Then you will see a big bracket, right? Close there. But you will go to the second row, right? Second row, continue. Inside the bracket, input the number 55, then go to the space to hit the 30, okay? So this way, you will have all the data in, okay? So make sure you input the data correctly, like the way I show you on the screen here. Okay, like that. You should have 8, 144, 55, 30 inside the big bucket. So when you have all this one, you are ready to get your answer already. I'm going to input my calculator now, 55, enter. 55, enter. And go to the 30, enter. So make sure you have all these 4 numbers. Under this one, this is the matrix A, okay? So after you input the data, you just go back, okay? Go back to stat, hit the stat, statistic, and move to test. And select chi-square test. Chi-square test. I don't have the chi. That's from the Greek again. I just use the bigger X to represent the chi. And the power, for presenting the square power, chi-square test. So you will see that one on your calculator. I think so, at the bottom there. ABC, the option C, chi-square test. Okay. So when you see that one, just hit the enter. Then after you hit the enter, you will see the screen will confirm we have observed value, which is our data input at the matrix A. They will confirm this one. And we give you expected value, expected. Expected value is like the book shows us how to you find out the mean. Expected value, H is the mean in average. Each row and column combined here. What is the expected value? And it will form a matrix again, a table, okay? And they will put for us as B. So if you use a TI-84, you don't need you don't need to do the calculation like a book give us that formula. You have to multiply row number times the column number, divide by total to get each number. That's just a lot of work to finish. You just need to learn this step, how you set up that data given to us, 8 original data under the matrix A. Then that's it, okay? The calculator confirm with you. You should have observed the value A, expected value B, and you will see the color. We don't need the color, so just skip, go to the calculate. Calculate, go to calculate, okay? And when you see calculate, you just confirm, enter, okay? Yes, calculate the value for me, okay? So hit the enter. Your answer should have come out already. I already got my answer. So after you hit the enter, we obtain the value test statistic, right? Chi-square. They will give you the chi-square already. There's chi-square equal 98.70030. A lot of number there. But I believe this problem just asks us to round to 3 decimal places. So you will do rounding to the 3 decimal, 98.700. Okay. And you need to keep that 00, don't omit it, okay? Because when problem says 3 decimal, you have to keep the 3 decimal like that. And that's just tell the people this is different from 98.7. Because 98.7 is exactly divided and finally come out just 1 decimal only, okay? 98.3 decimal here, even 00, that's tell the people it's rounded off, okay? We still have more decimal behind, but we just round off as required into the 3 decimal, okay? So you need to show that 20 here. So this is the answer for question 3, okay? So question 3, you will do this way. And this example is trying to show you how to use the chi-square test. Now, you know, when we do the chi-square test, you still need to learn how can you draw the decision, right? That's very important here. So to draw the decision, I will say, just check what's the p-value. And you can see your calculator shows we have p-value there, so small. Just write under chi-square equal 98.700 something here. You will see a p equals something, which is a 2.937575, and you will see e negative 23. You need to learn this part too. This means the exponent go to the negative 23 power, okay? This one is equivalent in algebra. We said 2.9375 and 75 and multiply base 10 and go to the negative 23 power. And you can see how small this is, okay? Negative power is a decimal point and with a 23 decimal point. So it's like 0.0000023, then 23, okay? 23 spaces here to multiply with 2.93. And this is in algebra, we call scientific notation, okay? So this number is very, very small, okay? It's like 0.0000. You need to have about 21 zero, then you 21 zero, then 22, 23. Total will become the 23 decimal. So small. That's why this is almost zero, right? In algebra, we consider this is zero. So the p-value is so small. And when p-value is small, less than alpha, if you need to do hypothesis testing conclusion, they will give you a significance level. And if they say, oh, significance level is 0.05, then this is, of course, this is smaller, right? This is less than 0.05. When our p-value is smaller than the alpha, whatever alpha give to us, okay? Any problem can give you any alpha. If smaller than the alpha, we can reject no hypothesis, right? So we help you to conclude that we reject no hypothesis. And what's the no hypothesis? We always assume there's no relation. Okay, they are independent. Then, if we reject that one, then we can support the other claim, the alternative. Yes, they do have some dependency here. The category affecting our category A or B here, affecting our population number 1 or number 2 here, doesn't make a difference. Okay, and if you apply to our political voting here, just like who are Democrat or who are Republican, really we are affecting our voting result here in our population, even population from the California or population from the New York will be affected by how many people belong to each party here. That's just try to tell us here, okay? So conclude, reject the no hypothesis. So for every problem asks you to do more, you can do continue. But this problem only asks you the chi-square test statistic, not using the evidence, the data we collected from the sample, and draw some conclusion. And this is what we got. The chi-square value is very large. And in that case, our p-value is very small. So p-value very small, it's smaller than any alpha given to us, significance level. Therefore, we can reject no hypothesis. And our no hypothesis for this type of problem, the no hypothesis, we always assume there's no relation, okay? They are independent. And for the homogeneity test, you try to check first one is equal to the second one or not. We always assume first is equal. Then alternatives are not, one of them is not equal here. Okay. So this is a good example for you how to apply chi-square test. And remember, when you do chi-square test, you need to use a matrix. Okay, matrix. So when you do the data entry, you need to hit second, and the key here, key button shows X with a -1. Okay. And I don't know, do I remember? Yes, we did. I was wondering, did we hit the recording? I think so we did. So this is a type of the question that they need to apply chi-square test. And you should be given a data like this, a table style. But in algebra, we call this is, you need to use a matrix, the raw data, column data, then compare, okay? So chapter 11 is very different from your chapter 9, earlier chapter, okay? It's a different type. That's why we call chi-square test. We compare the relationship and between the categories. So by now, if you have discovered any problem from chapter 11 that they like to share, I can stop mine and share with yours. So let me stop share this one and waiting for your questions. Do you have any questions? Okay. So we have how many people here? Now, let me. Okay. Let me take a record of our participants first. Jessica, Tiara, Michelle, Margaret, Stephanie, Yvette. And who is a Zoom user? You put a Zoom user, you don't get the credit because I don't know who you are. Okay. Who is a Zoom user? You need to give me the name. Okay. Because whoever participate our Zoom meeting here, you will get your participation credit of 10 points. So after our meeting, I can enter your credit into the grade book right away. But if you didn't give me the name, I don't know who I'm going to give you the credit. So let's go back to our homework. For chapter 11, there's one more type I'd like to share with you. Let's see. Besides this test, we have one. If you check the calculator, when you go to stat and go to the test, you have one more test here. We call chi-square GOF test. Okay. You may wonder, what is this? For what for? Okay. This one is also for chapter 11. So let's go to chapter 11. And this is chapter 11. Yeah. Sure. Chapter 11, besides, you use a matrix to do the chi-square test. If you know how to use this, it's very easy to use, okay? And we save you a lot of time to do those algebra work. And, like a question 6, okay? I think I need to help you the question 6 as well. This is a different type of question. Question 6. Let me copy this one and put on the whiteboard. Control C and go to whiteboard. Or maybe, do I need to open another new board? Let me see. Oh yeah, we can move. Okay. So I need a room to do the new things for you. So remember, you need to use matrix to do chi-square test. Okay, very important to remember this. Now, another type of questions. Such as the one we just saw it, question 6, right? Question 6. We have, and I need a Control V. Oh, I cannot do inside. I had to do outside. Control V. Yeah. Question 6. Look at the question 6. We only have one category only, different from the problem we did. Number 3, which we have 2 categories. We have horizontal and vertical, right? For the question 6, you only have one, okay? One category, A, B, C, D. There's no another category. The other side, this one is observed value, frequency, the data, okay? So this type of problem, you need to use your TI-84 and recall you need to use another test. And that's it. You have to go stat and test. Go to stat, test, and select the one called chi-square, GOF, okay? Chi-square, oh, chi-square, chi-square, GOF test, this one. This is the one you are going to apply, okay? So we may practice with this one, okay? GOF test. And this test, you need to input, observe the value under the L1 and expected value under the L2. This one, we need to use that edit to input your data, okay? Only the chi-square test, that one you use the matrix. But for this one, we go back to the same thing there. But this one, you have to watch out what's the degree of the freedom. We have A, B, C, D, 4 category. So degree of freedom is 4 minus 1, 3, okay? But how can I input the data here? You need to under observe the value is this one, 17, 26, 31, 17, okay? And expected value is like in average, okay? So in average, what we do is depend on problem given to you here, the null hypothesis. They say proportion of the category A is 0.2 of the probability, okay, or 20%. And B is 0.2, C is 0.3, D is 0.3. You need to change this one into the number, okay? Same as we have observed frequency here. So how can I do it? You need to do some math here, okay? So I'm going to show you how to do it. First, I will add up the total number of the frequency, okay? So find the total. So the total is 17, and help me to add up, okay? 26 plus 31 plus 17, which is equal. Anyone got a calculator? If you add up, let me know what's the total you have.
$91.
91? Thank you. 91. Okay. So the total you need to add up first, okay? Then after you get 91, you need to do some multiplication for each category, okay? So for the proportion A, for the category A, in average, they say the chance we get A is 20%, 0.2. So you need to take this 91, okay? So we have to do one by one. For the A, for the, maybe I just put the, for PA, okay? You need to do something to find the actual number. So you need to take a 91, multiply 0.2. So you will get some number, right? So what's the answer? 18.2, right? Like that. And find out the second category, proportion or probability for the B. So I will continue, work out this. For the PB, you take a total and multiply 0.2 again. So it's the same number, okay, 18.2. Then the third one, the PC, right? Probability in the category C, proportion problem said is 0.3 probability or 30%. So you take a total 91 and multiply 0.3, which is 27, right? 27.3. Okay. Make sure I do right. Okay. Okay, 27.3. Then we have one more probability or proportion for the category D is 0.3. Same thing. So they try to save our work. So we give you the same answer, 91 times 0.3, and that's give me 27.3. Okay. And you can see all the data we have here, and divide compared to the proportion, how many data in average should it be? It's given this number here that we call expected value. Okay, expected value. So you will input this number we just computed here earlier. Okay, onto our calculator now. Okay, so what I do, I go to my calculator, stat, edit, the one we used to do all the time, stat. Okay, so I go to my calculator, stat, edit, you hit enter, then clean out the L1, L2. I have existing data there. So you just need to use the up arrow key, go up and hit the clear and go down, and go up and clear and go down. So my L1, L2 is clean now. Then you start the input, right? You are going to enter, observe the value, enter data under L1. Okay, first. Under the L1, I'm going to put on my calculator now, 17, right? 26, this is actually what happened, okay? And 31 and 17, okay. So I input the data under L1, okay, on your calculator. Then go to the L2. So you input 17, 26, 31, 17 under L1. Then under L2, I need to input the expected value, that one by proportion, probability, okay? So I will use the one I computed earlier. First one is 18.2, right? So you just put it down, 18.2. Then the second one, same thing, 18.2. And the third one, 27.3. And the last one, same answer, 27.3. Okay. So you just need to input this data here. So I'm going to put in my calculator now, 18.2. Stand, edit. So L2, you need to put the 18.2 first. And 18.2, enter. Then 27.3 and 27.3. That's given proportion there, okay, for us to check, is this accurate or is not, okay? It's really for the null hypothesis set. The category A is supposed to be 20%, category B is supposed to be 20%, and C is 30%, and D is 30%. We are going to verify this, okay? Alternative is saying, no, they are not the same, okay? So after you input all this data here, the calculator will do for you, okay?
Are you doing this on the whiteboard? Because right now I can't see the whiteboard. So I've been trying to.
Oh, I went to the, I'm sorry, I went to the your
It's okay.
code site. I copy and paste, put the whiteboard, and forgot to share again. So sorry. Let me share again. I'm doing on the whiteboard because whiteboard I can show the work. Okay. So share. All right. So you had to stop me sometimes. I forgot and got excited and forgot I stayed the wrong side. Okay, so that's what I did. Okay, for the question 6, I copy from our homework, question 6 here, right? For us to see the data. And they give us the original data for each category observed actually from the observation of the study, we find out 17, 26, 31, 17. But the alternative, but our null hypothesis says we supposed to follow some percentage here, okay? Some proportion or probability. Like category A supposed to be 0.2, okay? 20%. B, 0.2 again. C, 0.3, and D, 0.3, okay? This is their hypothesis testing there. Supposed to be like this. But alternative said, no, it's not really follow this formula here, 0.2, 0.2, 0.3, 0.3. We don't know. We are going to testing, okay? Because by the observed value, look like the different. First one, second one is a different number. Third one, fourth one, C and D, 31, 17 is not a follow 0.3, 0.3, right? You can think of the 0.3 times the total 91. It's not the same number as the observed value. So that's why we are doing a test, okay? So this type of the test, you need to use the one I show you on the whiteboard here. You need to find the total 91, and someone helped me to get 91. And who did? Miguel? Okay. I heard a voice tell me 91. You
I
did.
did.
Thank you.
Michelle, you're welcome.
Michelle. Oh, Michelle. Thank you.
I'm moving along, but I'm putting because mine has a little bit different numbers. So
Uh-huh.
I've been
Oh,
following along with how you're doing it, but I
yes.
got lost at like the next step.
Oh, okay. So, but this is our example here. You give me, this is the example number, right? Okay, yeah. So you can follow the step and do yours, okay? Our number will be slightly different, okay? That's a computerized, they make a randomly change the number. So you need to find the number, okay? For each category, their proportion in average, what's the number corresponding to our total 91 here? So that's why I show you here, 91 times the 0.2, 18.2, okay? And category B, they say supposed to be 0.2 probability here, or proportion, 20% here. So you take a 0.2 times the total 91, come out the same number. Then same thing for the C and D, follow the 0.3, 0.3. So we got all the four numbers. That's supposed to be expected value, okay, that's what we call. So you are going to put this observed value, original value from observation, actually what happened. Follow the category A, B, C, D. We have 17, 26, 31, 17. You need to put this number under your L1, okay? When you go to stat, edit, put under L1. And L2, the next line, the next row, column, I will put the expected value, 18.2, 18.2. Let me see, do I do that one? So that's why I go to my edit. Yeah, I put 18.2, 18.2, 27.3, 27.3. And that's it, right? You just need to input these four numbers. Oh, my calculator frozen. Okay, I need to input my calculator again. 18.2, it was a freeze. 18.2, 27.3. And you can try with your data too. Okay, just follow the same way. Enter. 27.3, get here. Okay. So everybody put your L1, L2, okay? One is the original given data from the problem, and the other one, we use the given P, multiply the total, okay? So after you done this, hit the button, okay? So now I will go to hit the stat and move to the test and select chi-square GOP test, the one I wrote earlier here, okay? Here, chi-square, Control C, and copy that to here. Then you go to your calculator, do the same thing. I go to chi-square GOF test. That's the goodness of the fit test. Okay, original name is kind of long. Goodness of fit, fitting our proportion here or not. So hit the enter. You will see they confirm. Observe the value. The calculator will read from L1. Expected value will read from L2. And degree of freedom is 3. And that's correct. We have 4 categories here only. So 4 minus 1 is 3. Okay. Then go to the calculate. Go to calculate. Hit the enter. You should come out the answer, right? And you will come out obtain. This is my answer here. I obtain chi-square equal 7.8095. And there's more decimal, but we don't need that many decimal because the problem said report all the answer accurate to 3 decimal places. So I just need to copy the 4 decimal here. Then I do rounding from here to the 3. So I do the 3 will become 1, 2, 3, 4. Take the 4th decimal, compare with the 5. If the number is a 5 or greater than 5, I will go up as 1 unit, adding to the 9, right? So adding to the 9 will become the 10, so it'll be 0 there, and carry 1 to the left-hand side again. So I will become 7.810. Even the 0, I need to keep it. So people understood I round off, okay? It was not 0 there, and we have 3 decimals to tell the people that. So become the 0, and you carry 1 to the 0 there, and that will be your final answer, 7.810, okay? So again, the question asks you more, right? What's your conclusion here? You just check what's the p-value, right? You will check the p-value, and that is under your calculator here shows, under the chi-square shows 0.050116. That's my calculator shows like this. And usually for the p-value, we always round it to 4 decimal. So we go to the 4 decimal, 50, 1, 2, 3, to the 1, right? So if I got the 0.0501, if our significance level is 0.05, this is a greater, slightly greater, but still greater, right? But this number, of course, if the problem alpha is 0.01, then will be smaller, right? Will be greater. No. If the problem is 10%, okay, 0.10. If your alpha is 10%, this will be smaller. If okay, if alpha was given as 10% or 0.1, then we can reject, no hypothesis. But if the problem give the 0.05, I will still say fail to reject. Even the number is only slightly different only, but just follow the same rule. If the p-value smaller than the alpha, we reject, no hypothesis. And for the chi-square test here, or for the GOF test here, you always assume they are equal first, or they are independent here, or they are all the same. Alternative, we just say, no, one of them is different, okay? So that's what we draw the conclusion here. So at least today you learn how you use your graphing calculator to do the chi-square test and the GOF test, okay? Very useful. So you can avoid working on the algebra, complicated formula from the book give to us there, okay? Because the calculation of the expected value from chi-square test is not that simple. You have the raw number, time the column number, and divide by total number. it's kind of complicated. And a lot of decimal involved. Very easy to make a mistake. But if you use technology, TI-84, very easy to get down your answer here, to get your test statistic and the p-value. That's very important because we use the p-value to compare with the significance level to draw the conclusion that we can reject no hypothesis or not. Okay. Then from there, you can follow up. Can I support another alternative or not? Okay. So I saw more people coming in here. So anyone, do you have questions to ask me? Don't be shy to ask. Okay. Biget, do you have questions? No? Okay.
No, I haven't started chapter 11 yet, so I just started
Oh, try to
Still-
start. Yeah.
and I had a quick look at 11, but this has been super helpful because now I've got the shortcut. So that's,
Yeah, no, you don't need to struggling there to think about how I do it.
no,
It's-
I'm struggling enough. So,
Yeah, but you try to use this method here for these two types of question. We save it all the time and keep it accurate. Okay. All right, let's see.
thank you.
Yeah, Kiara, any questions?
Yeah, I have one question. So you know how
Sure.
we use the golf test? I think that's
Which
what it's
test?
called. GOF test.
GOF test is for this type
Yeah.
here.
But
Question
how do
6.
we distinguish if we're using the GOF test or the other one?
You,
Like,
you
is it
said,
based off of what the question reads, or like how we just see when it's multiple categories, then we use the GOF test?
they give you just one category only. You see, category. There's only one, A, B, C, D. No other category. And the
Okay.
other, yeah, then you use GOF, okay?
Okay.
And the other problem, we can go back and compare the other one. The other one, you can see that my screen doesn't move. Okay, let's see. Go back to question 3. You can see this one is a chi-square test. They give you category of the population. Another
Okay.
category is a category AB, right? Like I make up the example. A could be Democrat, okay? B could be Republican, like that. And you know the political party is different category of the population number 1, population number 2. Two different categories. We try to associate together to compare their relation. So this type here will give you two categories, okay? You use a chi-square test, use a matrix. And the type of the problem, like question 6, you can see just one category only, okay? Only A,
Yeah.
B, C, D. There's no other things to mention here. The other column is just data, okay? So when you see this type, you use the GOF test, okay?
Okay. Thank you.
You're welcome. All right. Any other question? This is a good question. And we just remember these key questions here and the steps. You will do very well in chapter 11. Okay. So we only chapter 11 and chapter 12, chapter 13. And chapter 13 is short, very short. Shorter, only cover section 1, section 2, that's all. And chapter 12, because we use the TI-84, we make the linear regression and correlation. We just need to hit the one function key here. We give you all the solution we need for the whole chapter. Okay. So that's why I encourage everyone to have a technology calculator, TI-84. TI-84 got one more function is for this one, for our chapter 11. TI-83 got everything except this chapter 11. There's no GOF test there. So for people use the TI-83, they needed to follow the formula to do question 6. Unless they have to go to the YouTube there to learn how can you change the programming into your TI-83. Because I know once I went there to find out, can we use the TI-83 to do the GOF test problem. And I pop out some some video, some instructor was showing you need to change your program on your calculator. You have to do the programming, but it's not too hard to do it, but it just you have to become some programmer to do your calculator shows the program there and input some language, right? Computing language and add on something to be able to use it. Well, but if you have TI-84, you got everything. What we cover in the class, okay? And you will feel your TI-84 very useful for the chapter 11, chapter 12, chapter 13. You just use a TI-84, will eliminate all those algebra calculation troubles, okay? All right, so, and thank you for waiting for me because earlier I had some technical problem here with my volume system, something wrong. But anyway,
Thank you so much.
Thank you. Have a
you're
good one.
welcome, and see you next week.
Have a good night.
Yes, we all need it, right? Good night and relax and good rest for tomorrow, right? Okay, bye bye, everybody.